Hello, manufacturing leaders, and welcome to Tools for the Trenches. In this session, I'm going to discuss the Kappa test, which is also known as an attribute gauge R&R. This tool is like the surf and turf of the Six Sigma menu, and that's because it's so good. But it's even better than that. It's like the surf and turf only costs you $10, and that's because the Kappa is so easy to use. It doesn't cost you a lot of time, energy, or money. And if your factory does a lot of visual inspections to decide if product's acceptable or not, then this tool is for you. Do you know what alpha and beta failures are? These are incorrect conclusions drawn from hypothesis testing. For your visual inspections, it's like this. If a product is good and you ship it to a customer, that's a correct conclusion. And if a product is bad and you don't ship it to a customer, that's a correct conclusion. But if the product is bad and you ship it, well, that's an alpha failure. And if a product is actually good and you scrap it, that's a beta failure. So you never want alpha and beta failures. An alpha failure puts your customer at risk, and a beta failure costs you money for absolutely no reason at all. The Kappa test can minimize alpha and beta failures, and it's unfortunate that more companies don't use it. In my entire career, I'm actually the only person I've ever seen apply it to visual inspections, even though it's a tool that's typically taught in Six Sigma black belt training. Whenever I completed a Kappa study, I've been shocked by the seemingly random visual product assessments by operators, QA inspectors, leads, supervisors, and engineers. The visual inspection results of each individual vary greatly without good controls in place. So I'll walk through the steps of the Kappa test now. And step one is to collect 10 to 12 product samples. And these samples, you want to collect samples that represent a full range of visual quality. So you want a near perfect sample, and then you want a sample at the other end of the spectrum that is obviously defective, but you want it to represent your process capability. You don't want to go outside of that. So maybe over the last week or a couple weeks, you found some samples that represent this poor quality, and then you found some that represent this perfect quality. And then you want samples 10 to 12 that represent this whole in-between range too. So if the samples meet that, right, and then you're going to try to evaluate those samples with a team of people. So after you have these 10 or 12 samples that represent your production range of quality, then randomly number these samples. And then you want to give these samples to individuals who normally assess them, like operators, QA inspectors, lead people, supervisors, engineers, and maybe even marketing. So everyone is assessing these defects independently. No one can see each other's results. Create a log of these and then enter the data into the appropriate statistical software. Now I'll jump into Minitab and cover the data entry. Note that I have no affiliation with Minitab, and it's a little pricey, but this Kappa study alone might justify the price. Otherwise, look online for some free Kappa calculators. So this is what Minitab looks like when you first open it up, and you have two sections. The bottom section is a worksheet, and this is where your data entry is going to go when you're doing a study. And the top section is the session section, and this will be where your results of a study get posted. So for the sake of time, I already posted some data in this Minitab worksheet. So what we have here are the visual inspection results of 9 different people. We have 5 quality inspectors, 2 quality leads, and 2 engineers, and they all evaluated the same samples to determine visually whether these samples were acceptable for shipment or whether they needed to be held up for rework or destruction. So if you look, Inspector V here said the first 5 samples were good, 6 was bad, 7, 8, 9 were good, 10 was bad, 11 was good, and 12 was bad. And each inspector did this independently, kind of alone in a room, and evaluated these samples. So if we look at it from a sample perspective, everybody thought this sample number 1 was bad, except Inspector V. And then sample 2, everybody thought it was good, except for Inspector Z thought it was bad, and Quality Lead 2 thought that sample was bad. So what we want to determine is whether we have consistency in our visual inspection process, or whether it needs some further further standardization. Okay, so let's run this data and see whether we have statistical confidence in this visual inspection system. So we're going to go to stats, come down to quality tools, come over to attribute Gage study. Our data is in multiple columns. So what we're going to do, I'm going to hold my finger on control, click all these, hit select. It's going to drop the information that we want to study over here. We have 9 appraisers. We have 1 set of trial data. And what we want to do is make sure our results, we want to look at this Kappa. This is important for us. So we're going to click this little menu here. So, okay, then we're going to run this study. Now you can see a bunch of information popped up here for this study. So the results got posted. And the main thing we want to look at is this Kappa information. And our Kappa result was a 43.4381. So this is the number we're going to talk about next. I'm going to copy and paste this over to a PowerPoint, and we can take a look at it in more detail and put it in context of whether these results are acceptable or not. Now we look at our results, we got a 0.4381. And if we look at our scale of what's acceptable, that's in the lousy range. Anything below a 0.7 is considered lousy. Anything between a 0.7 and a 0.9 is pretty good. And then anything above a 0.9 is really just great results in alignment on your visual inspection. So now we know we have lousy results. Let's take a look at what steps we can take to make that number a lot better. So our results indicated that essentially our visual inspections are yielding random outcomes. That means that we're getting a lot of alpha and beta failure. So we're shipping bad product to customers and scrapping good product for no reason. Here are the steps that we need to take in order to get better alignment and reduce inspection failures. Number 1, save your samples. These are going to be used again in the future. Number 2, create a small team of subject matter experts. Number 3, have this team use these samples to align their own assessments. Number 4, once they agree, then they need to write an inspection standard. And this standard should be a well-written document and include definitions of the defects, good pictures, and whether the sample is acceptable or a failure. Then everyone needs to be retrained to this new standard. And then finally, you want to rerun the Kappa test. Now the results should have improved significantly. So let's look at our new results in Minitab. So we're back in Minitab now, and we created that team of subject matter experts with the 2 quality leads and the engineers, and they got together and they got alignment on what these samples represented, whether they're acceptable or not acceptable. And they developed the standard. They took pictures, included those in the standard, and then trained everybody against the standard. So let's see how everybody's doing now. And we're going to compare everybody's results versus the subject matter experts. So let's go back up to stats, quality tools, attribute Gage R&R. We have the inspectors in here, V through Z already entered. So we have 5 appraisers, and we put a subject matter expert, a known standard or attribute. So the SME column, which was where the subject matter experts aligned on what these samples represented. So that's all in there, and we're going to run this study again. And let's see what it gives us here, right? So if we compare the subject matter experts to the individual inspectors, we'll see who is aligned now to the standard. So Inspector V, 1, that's awesome, right on track. Inspector W, 0.31, they need some retraining. There's a problem there for sure. Inspector X, a 1, that's awesome. Inspector Y, 0.82, I would accept that. There's probably just one data point where they're off a little bit, and there's a lot of gray area, so that's moderately acceptable. And then Inspector Z, right on. So made huge headway in our visual inspections, which is going to drive down waste and unnecessary rework. What's nice about the Minitab Kappa test result is that you can see how everyone does individually compared to the known standard. If someone's not aligned to your subject matter experts and their assessments, then you'll need to retrain that individual. And what's cool too is that when a new person starts, they can read the workmanship standard and then assess the samples and be entered into Minitab and get a Kappa score. And if they pass with a result of above a 0.7, then they can be considered qualified for that particular visual inspection. Ultimately, you don't know how aligned or random your visual inspections are until you run this test. And from my experience, I've always been shocked at the results. This may be a great opportunity for your factory, and if it is, I'm so glad that I shared it with you. The supervisor session on this topic and tools for the trenches goes into more detail, and I provide a real-life example from my past experience about this tool's application. The Kappa test is just one of many great topics that your supervisors can learn about. So enroll them today and create manufacturing experts.